Hi everyone. This is Jan Alarcon from the Quantum Tree Labs team. So today we're going to go into the second session of the StarNet Basecamp 2026. This is hosted thanks to the support of StarNet Foundation, OpenBuild, and Quantum Tree Labs. So in this session, we're going to explore more about the Cairo language. So we're gonna jump into this about the hands-on experience on the Cairo language. So this is the team. Mainly, this is me, Jan Alarcon, and Richard that will also give some as sessions for you guys later. So remember in the first session, we checked more about the Bitcoin, Ethereum, Starnet, and Layer 2. Now we're gonna check more about the syntax of Cairo language. Um, recap from the last session. We know there are two types of rollups, optimistic and CK rollup. Starnet is a CK rollup, and this CK rollup most of the time they are more secure and cheaper to use if we compare with other kind of solutions. So Starnet itself is a CK rollup, but also another better definition for this is validity rollup because they send validity proof. And these validity proof are based on Starks. This is kind of like a zero knowledge proof, but they use like a use case of a zero knowledge proof that changed into a validity rollup. So Stark proof, Stark itself, they don't, like, they are different than traditional snarks because they don't have this feature like a trusted setup, and they are like quantum secure. It's like they are resistant to quantum attacks. Starnet itself has its own VM. It means, remember, for Ethereum has the EVM, the Ethereum virtual machine. But for Cairo, we have the Cairo virtual machine. So at the end, they are two different ecosystems or two different VM that need to, interact each other. But at the end, they are very different. So each ecosystem has their own, own features and their own dev tooling and their own like rules and more. And that's why, for example, if you want to build apps on Ethereum, you need to, build apps using Solidity. But for build apps or smart contracts on Starnet, we need to use a language called Cairo. And remember, every wallet on Starnet is a smart wallet, that is a smart contract. Um, As we know, as part of the roadmap, Starnet is going to get integrated into Bitcoin. There are many ways that they are exploring, like a BitVM, Collider VM, OPCAT, you know. Some documentation here is very important for you guys that you can check more about the Cairo book, which is going to show you the syntax of the Cairo language, Starnet Foundry, how to use, this tool in order to compile and compile contracts and build tests. OpenZeppelin, because as the famous OpenZeppelin library for Ethereum, we also have it on for Cairo, where you have something like predefined contracts that you can reuse from them. The Starnet documentation itself, scaffold Stark, that is this full framework where you can have your backend, smart contract from all of them together. And you can also check more into Starnet by example, and Starly. So if you want to learn more about how to build apps uh, on Starnet, ideally this is the initial roadmap. Starlinks that will help you to get more familiar with the Cairo syntax, and then you can start building some, challenge, uh, building small apps one by one using the speedrun. I think we can say this is the very basic one. And after that, you can start using AI and more, tools that can help you to speed up your development. But before using AI, ideally we want you guys to, have a real touch with the language itself. Mm, so yeah, we're gonna do some live coding, especially uh, for this part for Starlinks. We're gonna use Starlinks. Um, so you can go to this part. You're gonna have, it help you to it's gonna ask you to connect with your GitHub, but you can skip it just if you want. But ideally, you should connect. I'm gonna skip it for now. For example, here it has some of my progress. So what I can do is like, okay, I'm gonna open a new window here. Let's see. Mm, So we can start working on this one. On this one we can move it. Let's see. It's taking a while. Mm, or we can try on this one as well. Let's see. This one is faster. Okay, this one. We can start working on this one. Okay, okay. Cool. So basically here this is gonna be we are gonna solve a bunch of exercises. It's like we're gonna do some hands-on experience directly into the Cairo language. So here is like, okay, this exercise, we're gonna read, what's going on here. This exercise doesn't do anything yet, but it still compiles. Cairo file getting run needs to have a main function. So this file is a valid Cairo file. So yeah, this is the very basic, Cairo file that can get compiled. So we just need to compile on this case. And then cool, and then you can move into the next one. And then this ancestor will compile. Can you make it compile? So we just, need to create like the very basic Cairo file. That is just gonna be like this, compile. Then cool, we're gonna go into the next one. Variables. So we're gonna start, okay, getting more familiar how to declare variables, what else we can do with this. So we have this main function, we have this variable x that we give it a value of 5, and we will try to print it. Yeah. So what is missing here is that we are just, declaring assigning the value like that. But in Cairo, we need to provide a keyword here like let. So this let is part of the syntax if we want to, declare a variable and also assign a value. Yeah. That's why it's a compiling. If I don't assign this, I'm gonna get the error. Yeah. Oh, I'm gonna get the error. Yeah, and you can see and you can check more here why is the error. But yeah, gonna move into the next one. Maybe compile having this. Okay, so in this case again we have this main function. We have this let x. We just okay declare a variable, and in this part we are trying to compare. Yeah, what is the value of the variable with 10. But actually we didn't assign any value. Yeah. So if we try to compile here, we will get error and yeah, we don't know what's going on. But you can click here, yeah, get a hint. So in this get hint, it's gonna explain you a bit more. You know, what happened if you annotate line 7, but it means it's line 2 with a type annotation. So what if we can give this type annotation? It means we're gonna give it assign a data type. Yeah? It can be less U64. Uh, sorry, U64, and then we try compile. Still not working, yeah? Okay. We give it a type annotation, but it's not working. What if you give it a value? Okay, we can give it a value. We can give it like a 5. And then at the end, it compile it. Right here. See? It compile. What if you do both? Okay, in this case, I did both, yeah? So, but I can remove this value also like this. So I'm gonna give it 5. I'm gonna give it this like this. And then it work, yeah? If I give in this, for example, like U64, oh, okay, wait, compile. It is working as well, yeah? So, but usually on Cairo, we can omit the data type and, during the compiling process, the compiler will realize, okay, it means like you're trying to use this value or the other value. And by default, at least for the Cairo language and the Cairo VM, the very basic data type is a field element. But usually we work more, with integers if you want to work on smart contracts. If you want to know more about field elements, we will check it in a while. Okay, next, we're gonna move into next because we solve it. Here is this one. So in this case, we created the value x and we are giving the uh, a type annotation, yeah, that it is a fail 252. It's a kind of like similar to integer. And then we are trying to print. But we are trying to print what? There is nothing, yeah? If we compile, it's gonna get error. So we need to give it a value. Oh, sorry. We need to give it a value. As before, like a 5. And let's see what we can get. Okay, cool. Compile. As you can, for example, if we remove this and try to compile again, it's gonna get the error, yeah? So as usual, you can always check here on the and get a hint, and it's gonna give you some, tips or suggestions how to solve this. Also, it is gonna give you the link of the book, yeah, of the Cairo book, where you can check it more there. Here is it. It's taking a while. So okay, we're gonna put assign some value here, and we're gonna move into the next one. Compile next. Oh, like I said, here on the Cairo book, you can, have a much better, like information or documentation how to work with this. So if you are not clear about something that we are, doing this exercise, you have to, read this and you will get more familiar with what's going on. Okay, in this case, what happens? Okay, this is also a challenge. We assign a value to x3, we print it, and then suddenly to x, we want to assign again a second value, it's like a 5, a new value as 5, but it's not gonna work because what? When we assign this, we are saying that we are creating this variable x, but it's immutable. By default, when you create this, it's immutable. So this is immutable, but later you are trying to update this value to make it mutable. So it's not gonna work. It will be like a fail. So if you want to, make it mutable, you just need to use this word, mutex. You need to compile, and then you can reuse this value later. Yeah, you can keep, updating the value there. Okay, next, to next, number 5. In this case, we are also creating a value, sorry, a variable called number. It's going to be the value of 1. And this is another way to assign the data type. What the data type is this one. In this case, it's like a UA, a byte or unsigned integer. And then we try to print it here. Then In this case, we also try, to update this value. But basically, on the comments they say don't change this line. So it means we cannot use as before this mute, yeah, because they say don't change this line. So the other way that we can work on this is to apply some technique that's called shadowing. You can check here, for example, if we go like if we compile, it's gonna fail, and if we get a hint here on this part, it's like in order to here is it's gonna explain a bit more, so we can read it. So because we want in variable 4, like in the previous exercise, we already learned how to make a mutable variable mutable. Okay, we just use this special keyword like a mute. Unfortunately, this doesn't help us much in this exercise because we want to assign a different type value to existing variables. So you want to assign anyway to the existing variable. Yeah? Sometimes you may also like to reuse existing variable names because you are just converting values to different types like this exercise. For example, by default, the um, the data type of this one is U8, but right now we are just assigning, number 3. And this number 3, if as we mentioned before, should be like a felt 252 data type, yeah, that is similar to an integer. And then that's why they mentioned this part also here. Yeah. Sometimes you may also like to reuse existing variables names because you are just converting values to different data types. They are different data types. So in this case, we can apply this technique like shadowing. So for shadowing is basically we're gonna give again let. We're gonna get one more let, and after that we can compile, and it will pass, and we can go next. And as you can see, there is a if we remove this, I'm gonna remove this. If I compile again, you will see like here there is also a link explaining a bit more what is shadowing, and what you can do with it here on this part. So you can check it out. Okay, I'm just gonna move into the next one. Let compile. Next one. Next one. In this case, we are also, let's see. It's taking a while, but let's try to do it. Okay, okay. Number 6. So in this case, we are, defining constant number. In order to have a good practice, you should use, this like uppercase words, not lowercase. Okay, you use this const number 3, const small number 3, like this. And it is not working because why? If you want to use const in Cairo, you have to do a, type annotation like this way. We can give any value to this one, like U16. And this is a data type on Cairo. And for this one, we also should give it like UA, for example. And this one actually no need, yeah. But let's try it here, compile. So, but for this exercise, it's kind of like special. Somehow the author of this exercise forced us to, to keep it like this, UA. So, okay, we're gonna follow them. But actually, this one is optional. Most of the cases, in order to keep your code clean, you don't need actually, this part. If you put just like this, is gonna looks a lot better. And then, okay, we move into the next one. Private types. So in this case, okay, we have the main function. We have this let is morning true, and then if is morning, and then we're gonna print this one, and then let's finish the rest of this line. Okay, we're gonna make it. We're gonna move like this. Okay. Okay, so it means we need to put something here. Yeah, let finish the rest of this line, or make it be false. Okay, let, and then we have is evening. So what we can do is just, okay, in this case, we are trying to use this is evening, but we haven't defined it before yet. So, okay, so we can put it like this. Um, let's see what happens in this case. Yeah, we are playing around. And there, it's like we just define the data type, but there is no any value, so we can put it like true. Nice. But you can say we can make it false also because we are just compiling the uh, this program. Oh, sorry. True. Okay, it's happened with true. We're gonna move into the next one. Mm, okay, this is the next one. I'm gonna move a bit more here. So we can read a bit more on this. We have this main function. A short string is a string whose length is at most 31 characters. Okay, yeah, so this is a good way. In StarNet Cairo, we have this like a field element that can be used also, to store these short strings, and therefore can fit into a single field element. That is the, file 252 that we're talking about. Short strings are actually fields, but they are not real strings. They are trying to, start to, simulate or match as a like a short, like a short string, but they are not actually a string like they say. Not the single quotes that are used with a short string. Yeah, we usually use like this part. Okay, so let's work on this. We have this. Let's mute my first initial. Okay, equal to C. This has a single quote, so it means it's like a like a short string. If is alphabetic, um, if is alphabetic, then we're gonna make a reference of my first initial, and then print, and then alphabetical, otherwise alphabetical, and print. Let's finish. Okay, the main part is this. Finish this like this line, like the example. What's your favorite short string? Try letter, number, any special character as a short string. So we have this is alphabetic, yeah. Okay, we have this ref char is numeric, and this part note. The following code is not part of the challenge. You have to make that. Okay, this we can ignore it for now. This last part. So what we need to change is this part. Yeah. So here we have this your character. Yeah, similar like this. Here we have my first initial, but in this part we have your character. So okay, I'm gonna put like this. Yeah. Let mute. I'm gonna use also mute, and then we can give it. They say any kind of number, okay, or a short string. Can put it as like a and try to compile and see what's going on. Let's put it like this. It's like this, like this. Uh, on this part, your character. Oh, we're missing this semicolon. Yeah. Mm, okay, cool. And then we pass. So what we are doing in this case, yeah? So we are creating this variable, and then we have this function that has been defined here, yeah? This is the definition of the function. That is gonna, take a reference of this character. So it means it's like just gonna create, like a snapshot of like a simple copy, but it's not gonna consume it. That's why we have in Cairo is like a ref. So at the end, we can keep using this, for example, this chart that is this your character, we can keep reusing later because in the function we're just passing a reference. Okay, and then internally, this is alphabetic function is gonna do some like some internal checks that you can check. Besides A, they say we can give it also, like any number. It can be A, it can be a chart from 0 to 9. We can give it. Let's see is if we give it like this, 5, what's gonna happen? Compound. Oh, I missed this part. Okay, compound. It's also work, yeah, because at the end, what we're using here as we mentioned before, this alphabetic is gonna get a file to 52, and this file to 52 is integer, is a kind of integer, but at the end it can store a smallest string, yeah. That's why before you can put the letter A or this number 5. So any of them is okay. Mm, okay, we're gonna move into next. We have some, okay, we can, it's also good to read this one, yeah, because we have some, so this, destruct the cat tuple to call print on each member. Okay, so what we need to do here is to get more familiar with tuples as we had on this case. So let's try to do it. So I'm gonna put this, so for example, in this case, we have the cat, okay, let cat. It has the name and age, yeah. Okay, so remember here, for example, here we are using name, but we didn't declare yet, and same for age. So how to destructor? So you need to create this parentheses and then name, age, equal cat. Let's see if it's compiled. Otherwise, we need to, check the book. Remember to always use the semicolon. And nice. It compiled, yeah. If you get some error, remember you can go to hint, and hint will send you to the book, yeah. So in the book, you can also check more about, like a tuples. In this case, it's gonna show you data types like the file element that I show you, the short string, the tuples, And here it shows you, for example, in this example, show you how to, destructure uh, how to destructure a tuple in this part. Yeah, you see? Just need to follow this. So in this case, we are doing the exercise, we are learning at the same time. Next. Okay. So modify the integer types to make the test pass. So in this case, okay, modify the integer types to make the test pass. So there are some tests here, but we need to modify the type, yeah? In this case, okay, we have this sum that is gonna take some UA, and sum up. And then you have this to do modify the type of this function to prevent the overflow when saving big values. Okay, convert to fail, convert to fail, convert to fail. So we're gonna use this. We're gonna solve first this test, okay? In this case, they are they are trying to sum up uh, two numbers. That is the like UA and UA. But remember, yeah, the maximum value for this is just 255, 255. If we try to sum up, there is not something like this, yeah, that might work. So what we can do is like, okay, we can define this as like 16. Let's try this way. This is the easiest way, yeah. But before we do that, let's read one more time. To do modify this test to use the correct integer. Don't modify the values. Uh, don't modify the values, just the types. Uh, see how using the UA suffix on the numbers lets us specify the type. Try to do the same with other data types. Okay, we will try it this way. Mm, some of big numbers, some of big numbers, and if it's gonna work. So we're gonna compile and take a while. UA convert to fail, integer, some of big numbers, something went wrong. Unexpected argument. Core. Okay, here, yeah, we need to also. So if we compile again, we should not get, this error. Let's try it again. We should get other errors, yeah, because we haven't finished the the other like tests. Okay, some big number. Okay, cool. We don't get the error anymore about some big number. Okay, let's move into the next one. To do return x as a failed, convert to failed. So we have this value that we need to convert to failed, and convert failed to a. Okay, so let's see the case. Yeah, in this case, so we have this. We're gonna pass this convert to failed. We're gonna pass a data type like a UA. But uh, we need to return a failed, yeah? So we need to do something here. So what we need to do is like, okay, this x is gonna be into something like this, and then let's see, let's try this way. Convert to failed. So we should not get any error related to this convert to failed. Okay, we're getting error about this because we haven't fixed it, yeah? So in this case, it's kind of easy. We can say that we have a data type UA that is kind of like a small number or a small integer, and we're trying to to convert into a data type that has a bigger size. So in this case, we just can use this a function into. So internally, the compiler will convert and use this bigger data type. But what happens in this case, yeah? For example, if we want to uh, convert a file to UA. So in this case, we are trying to convert a file that is a big size into some data type that is a small size. So in this case, we are gonna to do like some try. I'm gonna do it like this. X that try into, and then this unwrap. Okay. And then let's try it. Let's do this way. So here we are doing a try into. Okay, it seems that most of them has something went wrong with the codes. Let's attempt again. Sums 8 is okay. Something is failing. Some big numbers. Some big number. Okay, it seems like something is Failing here is a wrong, but before we jump into that, what is happening here is like we're trying to convert a small data type, sorry, a big data type into a small data type. So what may happen is like it might not be possible, yeah? So if there is a case that it might not be possible, we have to put like this try into, because this try into will uh, give you a enum. It's gonna give you like, okay, like a wrap number that sum inside his value or a error, yeah, or a known value there. And then we have to use this like unwrap. So in order to you guys check more into this try into, you can also check on the Cairo book and we'll explain a bit more on that. So in this case, they say this big sum number is failing. You guys can have a look again at that and I can fix it. We're gonna move into the next one. Operations. Okay, integer types implement basic comparison and arithmetic operation. File 252 operation should be avoided where possible as they could have unwanted behavior. Yeah, if you want play more with 252, it's very not, we don't suggest it. Better you guys always play with like integers, like this kind of number, U256, like this. In this case, okay, we have this function poly that's gonna read it's gonna have two inputs, X and Y, and gonna return something. Return the solution of X, like this, like that, fill me in rest. Okay. Test, poly, 53. So something easy what we can do is like, okay, we can do something like X time X uh, plus Y minus 2. And then we're gonna return this value. Res, don't change this. Okay, then we need to declare it. Let res equal to, okay, this operation. Don't change this test, don't change fill me. Okay, we can take this way. How is it? Then cool, it work, yeah. And this is a U size data type. You can also check more what is U size here, yeah. If you can copy and paste. We also don't use that much this U size. Ideally, you should always declare that U64 or U256 like this. We're gonna jump into the next one. This one operation. Okay. Remember last time you calculated division in Cairo 0? Okay, Cairo 0 is a very old language, but now we are in Cairo 1. This is like official Cairo. Has native integer type. Like, okay, yeah, as you can see before, Cairo has this like native integer types from UA to U256. U size which support like more operator than fails and always watch your overflows. In the last test, let's try to use them. Okay, so we have some modulus here. Okay, we need to implement some like a player on here. Okay, modulus, yeah, X and Y. So we can create this like a let res X modulus Y, yeah, like this. Floor division, just the classic like let X divided by Y. But yeah, like I say, that's always let's double check the division. But for now, we are gonna put like this. But maybe we're gonna come back to fix it. This multiplication, just x times y, but we need to give it, like a rest. Okay. Gonna create about letters. Sorry, letters. Mm, semicolon. Yeah, they should work, but maybe some of these tests are gonna fail, yeah, because we didn't put the right, value for y. I mean, we are missing something, yeah, on this operation. Letters. Ah, sorry, we're missing this. Assign. We need to assign like this. Assign like this. Okay. I missed the equal there. And then here, what we need to do actually is like, okay, we need to double check here on this part. Missing the token. Letters. Sorry. And what we can do here is like, if, you know, mm, oh, in this case, the tests are just passing, but you should always check that this value y is not zero, yeah? Because in this case, they didn't use zero, so it's okay. But ideally, mm, uh, we should put like other one more extra condition, like we have on the if. So, and then here we're going to explore more into these starlings. As you can see, we already solved a bunch of exercises, and you guys can keep doing and continuing to this. As you can see, you will practice all related to we already solved it all related to how to declare variables and how to play with data types and basic operations. But now you have to go, into if condition. What is the if condition? How to create, how to play or build like a functions like this, call me function like that. And then later on, you will have like a quiz, one more for functions. Yeah, we need to play more with declare functions and reuse it. You will have a quiz, and then you will go into loops. Loop or like like a for, how to use like a for or while. Enums are very important. I can say is it, when you master enums, you will improve a lot of your like as a developer. I think enums is very, very powerful, especially on Cairo and Rust, these two kind of language. If you master this data type enum, your smart contract later on will looks very clean. Same for options. So options, when you have options like that, it's gonna make your code more robust, and it's gonna be more easier to to create like a code, auditable code. Then it's very good to practice these two. And then we have the classic array. It's very classic like any other programming language. Structs also is okay, it's good to have. And then play a bit more on the what's going on there with the semantics of the language itself. And then you can go into traits. Traits is very important. It's similar to, like interface that maybe other programming language like Java have or C++, they have interface or like it's a mix of interface and, inheritance, but trait has their own, their own features that you can check also. As I mentioned, you can also check here, yeah, on the trades in Cairo. You can check here also on the Cairo book more about trades. That is gonna make also your smart contract more, robust and powerful. And then you will jump into dictionaries. That actually dictionaries we don't use that much for a smart contract, but it's okay for you, to master to play around with Cairo. Modules is important because it's part of the gonna help you to organize your files and your codes. So modes is good to do it. And then you will have few more exercises, yeah, on this part. So the idea for you guys is to complete all of this. So with this, you can, you will feel that you can actually build, create anything with Cairo. And at the same time, you will understand what you are doing, yeah? As I mentioned before, right now, AI is taking over everything. But before we jump into AI, we want you guys to have the very basics, the background. So later when you do AI, you will, okay, know, at least know what's going on, yeah? So that's why these kind of exercises are very important. Yeah, I think that's gonna be all from my side. I encourage you guys to fulfill all of this. And yeah, if you have any, some questions there, you later also can, contact me there in the group that we will have. Might be a widget group or any other group. We can discuss more about these exercises. Okay, that's everything for this session. The next session, you will learn more about how to build smart contracts. But for this session, you need to master the Cairo language itself. Okay, see you next time.